Hi everyone. So I wanted to make sure that everybody knew that we have resources available in Canvas in your course. Um, just click on your courses and access your course. And once you open up your course, if you go to the modules, and scroll down to the module that we're currently in, which is module 3. And right there, you'll see instructional content. For example, we're working on chapter 4.2 right now. If you click on 4.2, you have 5 work problems in this section. It will, if you click on any of them, these are videos, 8 work problems. If you click on any of them, a video opens up and show you how to solve that particular problem. It's really cool. And it's the problems are taken from the homework, so you're able to see them real time. Okay. All right, so I'm going to get out of this now, and we're going to go ahead and start chapter 4.2. Where I left off was dividing rational expressions, and I'm going to, although I completed most of it in class, I'm just going to go ahead and just start over doing it again. So let's get a new page here. Set up the page. And what I'm going to do is to use this. The video quality is not going to be the best because I'm doing a second-hand video situation, but here we go. So we're looking at dividing chapter 4.2, dividing rational expressions. Please recall that we already did multiplying, and we already actually did dividing in class. So I'm just recapping the process here. The 3 steps. 1, first use the KFC rule. Don't factor anything yet. Use the KFC rule. And that rule is keep the numerator flip the denominator and then change the sign to multiply. And the second step would be to factor. And then the third step would be to simplify. By simplify, we mean to cancel out. Anything that we can possibly cancel out. Okay, so we're going to look at a few examples now. Here, let's go ahead and start this example. X plus 5 over x minus 1 divided by x squared plus 2x minus 15 over x minus 3. So what I want to point out right here is this part here is the numerator. That whole expression is the numerator. And this whole expression is the denominator. So when I keep this, flip this over and change the sign to multiply. So let's do that. We have x plus 5, x minus 1. We know we're changing the sign to multiply. Flip this over, put the x minus 3 at the top, and x squared plus 2x minus 15 on the denominator. So now we can see that we need to factor x squared plus 2x minus 15. Let's go ahead and do that. X plus 5, x minus 1, x minus 3, and here we have x plus 5, x minus 3. So the good rule here is that since we're canceling, we're going to put this in parentheses, and we're going to go right ahead and cancel x plus 5 with x plus 5. This goes one time. X minus 3 with x minus 3. This goes one time. So 1 times 1 is 1. And x plus 5 on the denominator. And there's your answer. That's the simplest form for this problem. We have simplified what we have up here, what we started with as two rational expressions to a single rational expression. All right, we're going to do a few more examples for the section just to make sure that everything is clear here. So next example, I've got 2x squared plus 5x plus 2 divided by x squared plus 2x minus 8. This again is the numerator. This divided by the denominator, x squared plus 5x plus 6 over 2x squared minus 5x plus 2. So once again, we're going to follow the process of the KFC rule. We're going to keep the numerator, flip the denominator over, and change the sign. So let's go ahead and do that. We've got 2x squared plus 5x plus 2 divided by x squared plus 2x minus 8 times 2x squared minus 5x plus 2 over x squared plus 5x plus 6. So think that we have to go ahead and factor here. We're going to go ahead and factor the numerator here. I'm going to do that on the side here, and remember that I'm using the slide and divide method, so I multiply 2 times 2. And that gives me 4, so x squared plus 5x plus 4. Factor this. That gives me x plus 4, x plus 1. And then go ahead and divide by the 2 that I multiplied by. So this is x plus 2, 2x plus 1. So I'm going to go ahead and write that in here. X plus 2, 2x plus 1. Then I factor the denominator here. Two numbers that multiply to give negative 8. Add to give positive 2. X plus 4, x minus 2. Do the denominator here really quickly. That's x plus 3, x plus 2. Two numbers that multiply to give 6, add to give 5. And then we need to factor the numerator here. So we're going to do that on the side. So multiply the 2 times the 2, we have x squared minus 5x plus 4. Factor. Two numbers that multiply to give 4, add to give negative 5 would be x minus 4 and x minus 1. And then divide everything by 2 to give x minus 2 to x minus 1. Go ahead and write that in here. X minus 2 to x minus 1. Change the sign to multiply. So now I'm going to go ahead and cancel anything that can cancel out. So I can see that x plus 2 cancels with x plus 2. And x minus 2 cancels with x minus 2. Now, on the numerator, we have 2x plus 1, 2x minus 1. So this is a difference of squares. This is actually right, a plus b, a minus b. In other words, this is 4x squared minus 1 squared over x plus 4, x plus 3. Okay, this is the simplest form. Consider what we started out with here. We started out with all of this, and we ended up with this. So we've simplified this entire rational expression to give something that is worthwhile. All right, I'm going to do 2 more examples for you. So this is actually one more example would be great. This is 8x cubed minus 343 over 125 x cubed minus 216 divided by 4x squared minus 49 over 25 x squared plus 30x plus 36. So we want to take this expression here and go ahead and apply the KFC rule to it. So this is ax cubed minus 343 over 125 x cubed minus 216. Change the sign and flip this over. 25 x squared plus 30x plus 36 over 4x squared minus 49. Now observe that we have a difference of cubes here on the numerator because we have to factor this. This is 2x cubed, and 343 is 7 cubed. On the denominator, we also have a difference of cubes. This is 5x cubed minus 216 is 6 cubed. And right here, we're not able to factor this. This is not factorable because it's not a perfect square trinomial. Remember, the perfect square trinomial, if this was 5 squared and this was 6 squared, the middle term would have to be 60x. So this is not factorable. So we leave it alone. And then on the denominator here, we established that we have a difference of squares. This is 2x squared minus 7 squared. So let's go ahead now and we're going to apply the difference of cubes rule here. So recall that rule says we have 2x minus 7. The negative sign is in the binomial parenthesis. Then we square the 2x, multiply the two terms. Now we have 7 times 2 is 14x. Remember that how the signs work here, and then 7 squared is 49. The rule says that if we have a difference of cubes here, the minus sign is in the first parenthesis only. Follow the same process on the denominator. It's 5x minus 6. Then 5 squared is 25x squared. 6 times 5 is 30x. And 6 squared is 36. Okay, let's make this look nice. 36 times. But like what we have on this side, this is 25x squared plus 30x plus 36. And then we use the difference of squares formula here. So this is 2x plus 7, 2x minus 7. Observe here that we can go ahead and cancel this big term right here, this big expression right here. It cancels here. We can also cancel 2x minus 7 with 2x minus 7. And that gives you your answer as 4x squared plus 14x plus 49 over 5x minus 6, 2x plus 7. It is not necessary to FOIL the denominator. This is a great answer, and it will be accepted by the iMathAS system. All right, so that's what I have for you for chapter 4.2. We will pick this up at chapter 4.3. Please work on your homework.